All right, hello again, class. So today we're going to be taking a look at section 4.3, differentiation rules for sinusoidal functions. And as you can see, we're going to take a look at a few different things you've already looked at. The power of a function rule, which we've already taken a look at. So just to quickly review, we've got a couple items here. So when you have a power function, that's essentially something to the power of a exponent. The derivative becomes exactly what you see here. So the exponent becomes the coefficient. Decrease exponent by 1. And don't forget, chain rule. Never, ever, ever forget your little chain rule. All right. So that's important to note. And then your product rule, there's the little memory tool we talked about before. And yes, you will have to know a couple of little identities for this section to get through some of the algebra. One of them to keep in mind is your double angle identity. And in this day and age where we're using a lot of technology, I want you to make sure that you remember to protect yourself from identity theft. Dun, dun, dun. Something to make you smile. Okay, I know my humor's not the greatest, but what the heck? Gotta laugh these days. Anyway, let's move on to some examples. So how we're going to be doing is algebraic differentiation. So the key thing is to decide what rule you're going to use and how you're going to apply it. All right, so we're just going to go through a bunch of examples here. So as you can see, this first example in A asks us to differentiate. And the key aspect here is that you have the variable, just going to set something up here, I don't want to highlight too much, x here and x there. So the rule that you want to be applying is your product rule. So you'll be very aware of that because you have two separate functions here, one there and one here. So this is going to be an application of your product rule. Okay. So we'll just run through. So again, it's f. So you're taking your derivative. Oops, I already had a little blank there. So just to figure that out. Okay, so this notation requires your dy by dx, since it's starting with y, and it's f prime, which is 2x, times g, which is just your sine x, plus your f, and then your g prime. Derivative of sine is cosine from your previous lessons. And then from there, it's just a simple matter of doing a little simplifying. And yes, you will have to keep in mind common factoring is part of the simplifying process. Oopsie, my little thing is getting a little messed up around here. Okay. So for the next example up at the top here, this one here. Now, the way you can think of this one is a power. It's not absolutely necessary, but we'll see a little bit later on that it may become a little bit more important. So the way this notation is, you get a simple trig function, but key thing is the angle that you're given is a little bit more complex. So when you're taking the derivative, again, you're looking at trying to figure out what rule you want to use. And the only one you're really going to have to use eventually, obviously the trig rule for taking the derivative of cosine, but then eventually you're going to need your chain rule. So let's see how this plays out. So again, dy by dx is the proper notation. Your derivative of cosine is negative sine. Keep the angle exactly the same as what you're given, all right? But then your chain rule requires you to take that expression, that's why it's highlighted in blue, and take the derivative of the inside. Now make sure you can follow this. So you've got derivative of 3x squared is correct, 6x. 6x. And pi is a constant. So when you take the derivative of pi, you're going to be adding in nothing. That's why the only thing you need to worry about is just the 6x. Right? And then after that, it's a simple matter of just rewriting it in a format that's a little bit more acceptable. That's all. Okay. Alrighty. So moving along here, just going to get rid of one of these little items. Okay. So the follow-up to this one here is another example. So here again, 3 things you need to be concerned about. You've got a function that is a power. You can notice this power right here. So that's where the power is coming from. So it's actually cosine of this angle to the power of 2. It is a trig ratio that you have to take the derivative of, but then you also have to worry about the angle. And this is the order you need to take care of your rules. So power rule, taking care of that, and then the derivative of the trig and derivative of the angle. So let's see if you can follow us along. So your y can be rewritten in a way that's more convenient if you wish. You don't have to, but probably not a bad idea. So that'll emphasize the fact that you need to use the power rule, or sorry, power law, and then the chain rule twice. So let's see if you can follow us along here. So we've got, let me just get a pen that I'd like here. There we go. Magic one. All right. So we first need to use the power law. Okay. So if this whole thing is your base, and there it is, then we need to use the power law by taking this value as a coefficient, keeping the base the same, decreasing by 1. So there's the 2 as the coefficient. Keep everything else the exact same, right here, to the power of 1. And that takes care of the power law. All right. So that's that. Followed by chain rule. Now the chain rule here is going to require us to take the derivative of the base. Okay, so derivative of the base. So that's going to give us negative sign for derivative of cosine. Keep the angle the same. Okay, and leave that as is. But then the other part of the chain rule is going to ask us to take the derivative of your angle. So that's why it's important to make sure you identify the different portions when you're taking a derivative. Really important. Okay, and that is going to be your hardest part. The simpler part is supposed to be your next following steps, which is simply to rewrite it in a more compact way. So I put these blue bars in here just to emphasize that they're separate. So this is a sine ratio, this is a cosine ratio. Same angles as you can see, and then you just simplify as much as you can. Now, this might seem a little scary for some of you, simply because, just for a sec. You're probably wondering where the heck this came from. Now, the back of the book will have some very interesting results sometimes for answers, and what they're using is the double angle formula. So let's see if we can handle this one. So you have a sine and a cosine, but the sine and the cosine have exactly the same angle, okay? And even though it says negative 6x. So this is a double angle, keep the angle exactly the same as what you have here, what you have there. So just to quickly go back, look at the double angle formula. You have the same angle here and here, a sine and a cosine being multiplied together in a factor of 2. So back to this question. So taking out a factor of 2 here would leave us a 3 and the negative x squared. So this encompasses, this expression here encompasses the double angle formula. Unfortunately, the textbook will have some answers that rely on you doing this. That's why I'm showing you. Okay. Now, as far as I'm concerned, if you can get here, I'll be happy. All right. Just trying to make sure that when you're checking answers at the back, you'll be okay. All right. Let's move on. So just to make sure you're focused on what you need to focus on here, folks. Alrighty. So this next one here in D is again an application of the power law. Now it might seem a little weird, but this is a cosine of theta and multiplied by theta under this radical. So that's how you would write it as a power. Now the interesting thing as you write this as a power is that you have a very interesting base. So since the base is rather complex, we're going to be very careful with this one. Now, notice the notation again. So you have f theta. So f prime of theta, there's your independent variable. You're going to first apply the power law, then we'll take a look at what other rules. So you need to take that exponent as a coefficient, keep the base. Now keep in mind your base is right here. Okay, keep that base exactly the same. And then it'll be to the power of 1/3 take away 1, which is -2/3. Guess which rule you need here? Absolutely, you need the chain rule. Now, I didn't have enough room to continue this, but the chain rule would then tell us to take the derivative of this base and multiply it by what you see here. Okay, so all of this is going to have to get multiplied by what you're going to see down below. All right, so this implies a use of the product rule. Why product? Because you have the independent variable there and there, two separate functions being multiplied together. All right, so f prime is 1, derivative of this with respect to theta, times g, cos theta, plus f, which is theta, and then g prime, derivative of cosine is negative sine. So all of that needs to be multiplied by what you got up above here. Okay? All right, so again, that's the hard part. And the more challenging part is then to simplify. So just to make sure you've got this all sorted out. Because this is a negative exponent, this will eventually be in part of the denominator, as will the 3. So everything you see inside the square brackets stays in the numerator. There's your denominator. Okay, and then more often than not, your textbook will have a more sophisticated way of writing the answer. And this is acceptable as far as I'm concerned. Okay. So I know those examples are a little complex, but as long as you take your time, you should be fine. We're going to move on to a couple more. This is again, your typical example of determining slope of a tangent, which you've done before, just that obviously the function is a lot more complicated. So your slope of the tangent is going to involve doing what? Well, I would hope you would know by now that your slope of the tangent would imply finding your derivative. All right, so that's what this is going to imply. Slope of the tangent is your derivative at t equals pi. So your independent variable is t, all right? So your big task is to take the derivative of this function. So again, let's take a look here. So you have the variable t here, but then there's a separate function with the variable t in it as well. So what rule do you think applies? Correct. It would be your product rule. So this is where you're going to have to use product rule to complete this derivative. So that's not too bad. Just again, you got to be patient. So derivative here, f at t would be f at t prime, right? And then let's see if you can follow what's going on here. So we have the derivative of f prime, g, and then we've got f, and then g prime. Now make sure you can follow g prime. So g prime derivative of sine is cos. Keep the angle the same. But then this is a separate angle, so you need to chain that chain rule to get the other two in there. Always have to take the derivative of your angles when you're dealing with trig. Now, oftentimes you won't see the angle written with brackets. That's why I've kind of not written it here. So when you're looking at your solutions, please be careful. So again, this is the hardest part, is to find all of this wonderful derivative, and then it's supposed to be relatively simple from there. So just a little bit of simplification here. And now, since the goal of the question is to find the derivative at t is equal to pi, I wouldn't be too concerned about factoring. It might make your life a little easier, but not absolutely necessary. Okay? So you are asked to find the slope of the tangent at t is equal to pi. So your slope of the tangent is your derivative function evaluated when your independent variable is replaced with, in this case, pi. So you just put your pi symbol in there. This is where you got to remember some of your trig values, though, that the sine of 2 pi is 0, and the cosine of 2 pi is 1. And then your final answer, m at t, slope of the tangent, is 6 pi squared. And you don't have to turn that into a decimal at all. Okay, just leave it as is, you'll be fine. Don't worry about it. Okay, and just to double check, yeah, one more thing to get through. This one here. So this one, a very similar type of question as to what we did, a little more complex with the algebra, but now we're looking at finding the equation of the tangent line. So the equation of the tangent line right here. Remember, a line always has that format of y equals mx plus b. So your slope here in this equation is actually your slope of the tangent, which means you need your first derivative. So you got to take the derivative of this expression, okay, and then evaluate that when x is pi by 2. So even though you're given an ordered pair, this is the focus number that you want to use. All right. This value will be helpful in finding your y-intercept later. So let's get through this process, which we've done before. Now, I've decided to go ahead and use quotient rule. So if you remember how the quotient rule works, so it's n prime d, numerator, denominator, minus n, numerator, d prime. So derivative of sines cosine. This again, though, is your chain rule. Okay? And then the denominator is your denominator squared, d squared. All right, so that's the pattern we've looked at for a quotient rule. Feel free to use the product rule if you wish. You'd have to rewrite this function as cos x times sine 3x to the power of -1. Okay, that's not a problem. Because again, the main thing is to be able to find this derivative when x is equal to pi by 2. All right, because we need that to get the slope of the tangent. So as ugly as this looks, it's just a matter of being patient. There's the proper notation for the slope of the tangent. All right, so dy by dx. Substituting in, so you do have to know your trig reasonably well to be able to get these answers. Now, obviously, using a calculator in radian mode is perfectly fine too. Make sure you have that available. Substitute in all your numbers that you need. All right, so those are all the proper values, matching what you've got there to get a final result of, oh, look at that. All worked out to a nice number of 1. Once you have the slope of the tangent, you go ahead and use your grade 9 techniques. So this is the x from the ordered pair, the y from the ordered pair, solve for b. And then you can just continue from there and get your slope of the tangent working to find your y-intercept. And again, the goal of the equation was to find, the goal of the example was to find the equation of the tangent. And there it is. And that's it. All right. So as far as your practice questions are concerned, the practice questions are listed in the handout if you wish, or feel free to just do as many as you possibly can to occupy yourselves and keep your minds going. And please keep an eye on your Google Classroom and Google Calendar for updates for different evaluation items and whatnot. All right. Take care, folks, and stay safe.